Right, boys and girls, we've got the heart today. I'm just going to focus on the structure of the heart, how blood flows through it, and a bit about valves. So I'm going to talk about the structure of this and the components in the heart, starting on the right hand side, because it would be like right hand side, left hand side, like that. So first of all, right hand side is about deoxygenated blood, and deoxygenated blood goes to the lungs and then back around to the heart and then to the rest of the body, everywhere around here to the rest of the body. So at the start we've got the vena cava, these two things here. You've got the superior vena cava on the top and you've got the inferior vena cava on the top. You just have to know, just be aware of them. I've never seen that come up in a test or anything, so it might do this year or next year. Now looking at the right atrium here, which is the first chamber that the blood flows into, and the first chamber's got these two pincers on it which are valves, and that is called the tricuspid valve or the atrioventricular valve, and that will lead to the right ventricle, and then the semilunar valve, which are these two small pincers here, and then the pulmonary artery. Now moving around, where the blood flows into, the oxygenated blood flows into once it's gone from the lungs, you've got the pulmonary vein, left atrium, atrioventricular valve, can't speak today, or the bicuspid valve, left ventricle, semilunar valve, and then the aorta. That is pretty much the components of the heart, or the structure of the heart. So I'm going to talk about valves now and why we have valves. So valves, what they do is they stop the backflow of blood. And how they do it is this. Valves only open in one direction, so imagine this valve here only opens like that. Now, it's to do with pressure and why they open. So if you've got a high pressure this side, and the valve only opens this way compared to the low pressure here like this, the valve won't open because we know that pressure moves from high to low. So it's going to, the fluid or whatever is in here with the high pressure is going to want to come down this way, but it's not going to be able to because this valve will not open that way, it only opens that way. So we've got a case where it actually does work because we've got high pressure here and low pressure here, which forces the valve open this way because it can only open this way, and that is how valves work. Now moving on to how blood flows throughout the heart, we're going to start with the right ventricle, the left hand side, which is the right hand side to me, but the left hand side, just to let you know, both of these things happen simultaneously. It's just hard to explain when I have to explain both at the same time. Bit hard, so I'm going to focus on this one, but know that the right hand side does do the same thing as the left hand side. So blood will flow in from the pulmonary vein into the atria. Now what will happen is this will contract, the atrium will contract, which will shrink it down, decrease the volume and increase the pressure. Also that blood flow coming in, that will increase the pressure as well. So now that will form, I'll come on to that way there. Atria is contracted, decrease volume, increase pressure. Ventricle relaxes, increase the volume, or the same volume is maintained and it decreases the pressure. So we've got increased pressure, decreased pressure, and we've got a pressure gradient formed, and the valve will open because it's going to open that way. So blood will flow straight down into the ventricle. Now, when it's in the ventricle, which is stage 2, the ventricle will contract, this part here. That will form a decrease in volume and increase in pressure. Now this increase in pressure in here will be greater than the pressure which is formed in atria. So that will form this scenario here. And that will cause the valve to close, or it won't open. So it won't allow the blood to flow back this way because we know that the blood flows from here up the aorta and then out to the rest of the body. So that will cause this to stop. But now we've got an increase in pressure in here, and the pressure in the aorta is lower than the pressure in here. So the pressure between the ventricle and the aorta, and the thing which is blocking it is the semilunar valve. There's a pressure gradient form, high pressure, low pressure. Semilunar valve will open, blood will flow up here and out. Now, when this happens, and then also the same sort of thing happens with the atria and the ventricle as it does with the aorta and the ventricle. The high pressure in here to low pressure will close that valve, and then the blood can flow out wherever it wants to go to. Now what happens in this stage, when the blood comes back round after going to all of the organs, it will come back round and it will come into the atria. Now it will flow into the ventricle passively because this will already have a higher pressure. It won't need to contract or anything. The valves will simply just open because there's already that blood flow or that blood or that substance in here, which will cause the valves to open passively into the ventricle. Now when this ventricle has the same pressure as in the atria, they'll have the same pressure, so there'll be no pressure gradient. So that is when the atria has to contract, which will decrease the volume, increase pressure, and will form that pressure gradient again, and they will get the rest of the blood out of the atria and into the ventricle, and then the cycle happens again. That is the heart. I think I've talked about that side and that side, about that being thicker. Yeah, I have. That's pretty much it. That's the heart. It's decent. I will catch you next time. Like and subscribe. See you in a bit.